Hello, we are continuing with chapter 3. We did section 3.1 and 3.2, and now we are combining section 3.3, 3.4, and 3.5. And we have three sets A, B, C with these sections. So it's a mixture of things going on here. So, but main thing is basically dealing with polynomials. So dividing polynomials, finding the factors of the polynomial, then given some information, creating the polynomial. That is what you will learn here. So first thing, dividing polynomials. This is considered a review concept. I hope everyone has seen long division of polynomials, but here is a quick review. Well, you know how we divide numbers. So the long division of numbers is very similar. The polynomial division is similar to the division of numbers. So what we do when we have a number to be divided by another number, so like here we have to divide 23 by 4. So this is called the dividend. The number which is being divided is called dividend. The number with which we divide is called divisor. And when we do this process, we get something which we call quotient. So this is the quotient, and then we also get a remainder. In the same way, when we are dealing with polynomials, with the division algorithm for well, you guys can read this or you already know that. So we say that given a polynomial being called dividend, and the name of the polynomial is f of x, and a non-zero polynomial divisor dx. So the polynomial with which we are dividing, where the degree of dx is less than or equal to the degree of f of x. So we can do the division if the degree of the divisor is less than or maximum it is equal to the degree of the numerator or the dividend. Then there will exist unique polynomials qx and rx such that we can write them like this. So this is called the basically division algorithm, or the rule that that governs the division. And q of x is called the quotient, and r of x is called the remainder of the polynomial. And the remainder might be 0, or if it is non-zero, it must have a degree less than, strictly less than, no equal to sign. So strictly less than the degree of the divisor. There is another thing here you might note. The degree of quotient is always equal to degree of dividend minus the degree of the divisor. So for example, looking at the next problem, it's example 1. Find the quotient and remainder using long division for each of the following. So here degree of the numerator is 3 and degree of the denominator is 1. So 3 minus 1 is 2. So the quotient will have a degree of 2. So how do we find that? So we make our division, Now, one thing that you have to make sure about is when you put the dividend in here, so dividend goes in here. Sometimes you have sign like this, and the divisor goes out here. So divisor is x minus 2, and dividend is the numerator. But when I copying down the terms of the dividend, in here I will keep my eyes open that is there any term missing, mean any power missing. Then I have to still write it or leave a space position, its position, for I kind of hold its position. Okay, but in this case we don't have any term missing because 3, 2, 1, 0. So x cubed minus x squared minus 2x plus 6. I copy down the whole dividend. Now the procedure goes, I hope everyone knows that we are looking for something. We are going to divide. We are going to find a term. Actually, it's easier to do. See, so take the lead term of the dividend divided by the lead term of the divisor. So what do you get? X squared. That is the term that is the first term of the quotient, x squared. Okay. this is the process that you begin. And now you multiply the quotient with the divisor. So you get what? X cube minus 2x squared, and you bring it here and put it under the same terms. Now we have to subtract. So in order to subtract, if we just put a negative sign here, then it's very confusing. It looks like the negative sign is only with the x cube term, although it has to be with the whole thing over here. So you may put parentheses and then draw a line, and now we have to kind of add them, or you can say subtract them. So x, we are subtracting like this: x cube minus x squared minus this term, x cube minus 2x squared. So you know what happens. We first have to distribute this sign. You can come on a side and you can write it like this: x squared cube minus x squared, and at the bottom you have negative x cube plus 2x squared. So if you cannot do it in your head, then you have to do it on a side. So from here only x squared comes out, and then you bring down the next term. And now again repeat the process. So we divide the lead coefficient, lead term, which is x squared, by the lead term of the divisor, which is x. So x squared divided by x is x plus x, positive x. So I put plus x over here, and then I multiply the divisor by this x. I get what? X squared minus 2x, and then put parentheses and subtract. When I subtract, I get 0. So I was able to divide this thing so it gave us x squared plus x. Okay. So now since it says find the quotient and the remainder, so you will say quotient is equal to x squared plus x, remainder equal to 0. Okay, now this is a little bit higher degree. So 3x to the 4th minus 5x cube, and now you see there is a x square term missing. So I can put plus 0x squared, or I can just leave a gap here like this. And then write the next term. So it's up to you. I like putting the 0x squared. And the dividend is x squared plus x plus 3. So again we start by dividing the lead term of the dividend by the lead term of the divisor. I end up getting 3x squared. So this is what goes up there. So it doesn't really matter, but it looks nice if you write it, because it's an x square term. So start with putting it above the x square. Now multiply the whole divisor by the term of the quotient. So I get 3x to the 4th plus 3x cubed plus 9x squared, minus sign outside. Then when I read 3x4 minus 3x4. So this cancels out. Then I have negative 5x cubed minus 3x cubed. So I get negative 8x cubed. And over here, I'm getting 0x squared minus 9x squared. So 9x squared. And I bring down the next term. So now my lead term is negative 8x cubed. And then I divide it by x squared. So I get negative 8x. So I put that here and repeat the process. Okay. And multiply the divisor by negative 8x. So I get negative 8x cubed minus 8x squared plus, no, again minus, sorry, minus 24x. Subtract. So 8x cube, negative 8x cube plus 8x cube gives me 0. So I can just cross them. Now negative 9x squared plus 8x squared will give me negative x squared. And then the next one, negative 20x plus 24x will give me plus 4x. Okay, so should we stop here? No. Why? Because one term of the dividend is left, and also the degree here of the remainder at this moment is the same as the degree of the divisor, so we have to still go. So again, doing the same process, we see that the next term of the quotient will be negative 1, because I have a negative x square here, and then I have a x square as a lead term of the divisor. So repeating the process, multiplying the divisor by the negative 1, I get negative 1x squared, negative x, oh sorry, forgot to bring down the 5, and then we have negative 15. Subtract negative x squared plus x squared, cancelled out, 4x plus x, so I get 5x, and then negative 5 plus 15, which gives me plus 10. Now the degree of the remainder is less than the degree of the divisor, so that will be our answer. So quotient is 3x squared minus 8x minus 1, and the remainder 5x plus 10. So this is how you do the division. Okay, the next thing is complex numbers. So we are looking at, so where did the complex number first arrive? Remember, if we have an equation like this, x squared minus 1 equal to 0, we can write it like x squared is equal to 1, and then I told you when you take the square root, you will get two answers. So x is equal to plus minus 1. Okay? But if we are dealing with this equation, x squared plus 1, then what happens? Then we get x squared is equal to negative 1. And in the past, we said if we take the square root, we get a negative number under the square root, and we are not allowed that because we were living in the real world. Okay, in the world of real numbers. So in real numbers, this does not exist, this kind of thing. So if we are looking for a solution, we say no solution. But now we are going to come to bring this in our real world, or world of real numbers, bring this type of numbers in there, and it makes the set of numbers a bigger set, which is the set of complex numbers. So we have a special notation for this thing, this radical, square root of negative 1, and we denote it by, we won't have a square. If I have square root there, then I won't. So actually the answer to this one, so I have the equation x squared plus 1 equal to 0, which I can write as x squared is equal to negative 1, and then x will be equal to plus minus square root of negative 1. So plus minus is, it's coming from there because we are square rooting. Now this negative square root of negative 1 is called I. It is denoted by the symbol I. Okay, so this is not a real number, and we say it is a complex number. And also note that I square, now in real numbers we don't have any number, does not exist any number which when squared gives you negative 1. But in complex numbers we have such a number, and this is the I. Because you can write it as I times I, which means square root of negative 1 times square root of negative 1, which is negative 1. And why? Because there is a rule that square root of a times square root of a is a. So using that rule, we get negative 1. Okay, now more about complex number. So this is kind of a unit, or just you can say imaginary part of the imaginary part of the complex number. So a complex number is an expression of this form: a plus bi, where I is equal to square root of -1, and a and b are real numbers. That's why I said this complex number is a bigger set than the set of real numbers, because it contains all the real numbers. So all the real numbers exist inside the set of complex numbers. So they are also treated like the real numbers are also treated as complex numbers, because, for example, if I have 2, a real number, I can write it as 2 plus 0i. 0 is also a real number. So this satisfies the definition of a complex number, that a and b should be real numbers, and then we have the one of them is multiplied by the I. Okay, so then we have that the real part of this complex number a plus bi is a, and the imaginary part is b. Okay, I think I will stop here. The video is getting longer, so I will the rest in the next video.